Hey, wanna live in Malaysia but the weather is too hot? You have a traditional air conditioner but your kids forget to switch them off? It can lead to a big electricity bills. Well, don't you worry, folks. Introducing Frostline. With the help of Micro P, you don't have to worry about switching off the aircon. Just enter your home, lay down, and the aircon will switch on automatically. Hey Frostline, I want to take a shower now. Do I still have to switch off the aircon? Don't you worry. Just get out from your place, and if the infrared doesn't sense anyone in the room, it will automatically switch off. Well, what if the temperature is already too cold and I'm too lazy to switch the aircon off? Don't you worry. With the help of Micro P, it will read the current temperature inside the room and it will give a suitable output. Frostline, make your day a little cooler.
For our introduction, our group decided to take an old air conditioner and observe the problems that the consumer had, hence find a solution to every problem. Our objective is that our group will take the traditional aircon and upgrade it by using a Micro P.
The scope of the project are divided to 5, which is the hardware limitation, program constraints, threshold sensitivity, timing and delays, and also the environmental dependence.
Next, we go to the method and methodology. Our system uses a microprocessor as the main controller, programmed with the AZ68K simulator. Sensors detect human presence and temperature, sending data to the microprocessor. The AC turns on or off based on this data, and a countdown timer shuts it off after a set time. Each component was carefully tested for reliable operation. To test the system, we started with simulation using the AZ68K emulator, checking 3 scenarios. No person detected, AC test off. A person detected but temperature below 18 Celsius, AC test off. And a person detected with temperature above 18 Celsius, AC turns on. Then, we integrated hardware connecting sensors to the microcontroller and using LEDs as indicators. For validation, we compare real-world results to expected outcomes. Finally, we tested response times to ensure minimal delays. These steps prove the system works reliably under various conditions.
For the result and discussion, based on the given pictures from the right left to the bottom right, we can see that the conditions are starting from where all the switches are 0. When all the switches are 0, it considered as the initial conditions where the AC system reading that in the room there is no presence of a human. But when there is a presence of human, the switch 0 will turn on and indicate at the LED 0, it will turn on. When the LED 0 are turned on, it allows the switch 2 to turn on. The switch 2 only can be turned on when the right switch of it are turned on. Same goes to the switch 2 and also switch 3. When switch 0 are turned on, it indicates that there is a presence of humans in the rooms. When the switch 1 is turned on, it indicates that the system are currently reading the room temperature. When the switch 2 are turned on, it indicates that the reading temperature are not equal or larger than 18 degrees Celsius. When switch 3 are turned on, it indicates that the AC systems are turned on. Thus, it will start to cool down the room temperature to the required level, which is 18 degrees Celsius. After 2 seconds in the simulations are considered as 2 hours in the real life time. After 2 seconds, the switch 0, 1 and 2 will automatically turn off, and after 2 seconds, the switch 3 will be followed to turn off also. This is because the systems assume that the room temperature already reached the required level, which is the 18 degrees Celsius. After a few seconds, the system will reboot and start again to detect the presence of human to the reading the room temperature until to determine either the AC system need to be turned on or turned off. In the discussions, we can see that there are 2 conditions that we want to prevent, which is we want to prevent that the AC system reading the room temperature when there is no presence of humans, and also we want to prevent the conditions where the AC system are turned on automatically even though there are no presence of human in the room. To prevent both conditions, we use the command cmp.b and also beq command. This will shows that the systems need to compare with the right side switch of the current switch are turned on to make sure that their right side switch are turned on, thus it can also turn on. If the right side of the switch are turned off, thus the switch cannot be turned on. This can be used to prevent the both unwanted conditions that we discussed earlier.
In conclusion, the system automates AC control, ensuring energy efficiency by operating only when needed. It's reliable in real-world use with future potential for IoT integration, advanced microcontrollers, and dynamic threshold for greater flexibility. Thank you very much.